Good morning to all. This is the third day lecture of the short course Satellite Meteorology Application in Weather and Climate Study. So this lecture is covered under the Azadi Ka Amrit Mahotsav also. So my lecture title is Application of Satellite Data for Tropical Cyclone Study. So first we will discuss some basic information about the tropical cyclone, then come to the satellite part. So first question is, what is the tropical cyclone? So tropical cyclone is basically a warm core system, and it is also a low pressure synaptic scale phenomena with organized deep convection which form over the warm ocean. So tropical cyclone generally it forms over the warm ocean, and when the low pressure developed, so that origin of this tropical cyclone start from the low pressure itself. So its synoptic scale phenomena is with organized deep convection. Synoptic scale phenomena means this tropical cyclone extend up to large scale in the atmosphere. So also in the tropical cyclone, there will be the deep convective cloud. Inside the tropical cyclone, there is a dense cloud, and it forms over the warm ocean. And another feature of the tropical cyclone is that it can extend vertically up to 10 to 12 kilometer in the troposphere. So tropical cyclone, it is not a horizontal phenomena, it is vertical phenomena also. It at a horizontal scale, it can extend 100 to 1000 kilometer, and vertical, it can go up to 10 to 12 kilometer. Another is because tropical cyclone is a rotating wind. So there is a rotating wind inside the tropical cyclone. So there is a specific phenomena of the rotating wind in the northern hemisphere. If you look at this tropical cyclone in the northern hemisphere at the surface of the tropical cyclone, so you will see that there will be the anti-clockwise rotating wind at the surface in northern hemisphere. If you look at in the southern hemisphere at the surface, it will be the clockwise. And in northern hemisphere, if you look at the top view of the tropical cyclone, there will be the divergent kind of wind is there. So already you know this is associated with high wind speed, heavy rainfall, and it can damage in the coastal area, and it can be bring floods, loss of property and life. So till now we have discussed about what is the tropical cyclone and what is the wind structure of the tropical cyclone. So we have seen that anti-clockwise rotating wind in the northern hemisphere is called as the that is the main weather phenomena in the tropical cyclone. But any anti-clockwise rotating wind can be called a tropical cyclone? Answer is no. We cannot call any anti-clockwise rotating wind, surface wind, is a tropical cyclone. For this, there is a criteria based on the wind speed and pressure drop at the center. It is set by the regional meteorological agency. It is valid in Indian Ocean. You can see low pressure once the low pressure forms, the wind speed should be less than 17 knots. Knots is the universal unit. It is used everywhere. If you convert into kilometer per hour, it will be less than 31 kilometer per hour. And correspondingly, that pressure drop at the center will be the 1.0. Further, if wind speed increase, in that it called a depression, there will be the limit. It is 17 to 27 knots in between, then we'll call the depression, and pressure drop will be 1 to 3 hectopascal. And then further, if the wind speed increases up to 34 to 47 knots, then we call tropical cyclone, and pressure drop will be 6.1 to 10 SPA. So further, it is categorized as a severe cyclonic storm, very severe cyclonic storm, extremely severe cyclonic storm, and then finally super cyclonic storm. If wind speed is greater than 120 knots, means that is the 222 kilometer per hour. And also that there is a regional name of the tropical cyclone. over the Indian Ocean, we call a cyclone. If you look at this Atlantic Ocean, it is called the hurricane. Western Pacific and South China Sea, it is called the typhoon. And over the Western Australia, it is called the valley winds. So there are mainly six major basins where tropical cyclone form. First is the Western North Pacific Ocean, this area. Eastern North Pacific Ocean, this part, it covers 90° west to 120° west and 5° north to 20° north. Southwestern Pacific Ocean, it covers 150° east to 180° east and 5° south to 20° south. North Atlantic Ocean, it covers 90° west to 20° west and 5° north to 25° north. And Indian Ocean divided into two regions. Above the equator, it is called the North Indian Ocean, and below the equator, it is called the South Indian Ocean. So we will look at the what is the frequency of the tropical cyclone formation over the year. So this bar graph shows the how many tropical cyclone forms each year during the period 1997 to 2022. If you look at this bar, you can see that on an average 4 to 5 tropical cyclone forms each year. If you see this bar, the particular year like 2018 and 2019, the formation of the tropical cyclone was slightly higher as compared to the other years. If you categorize these this increase in 2019 and 18 because of the more number of tropical cyclone in the Arabian Sea as compared to the Bay of Bengal. So more number of tropical cyclones have formed in the Arabian Sea as compared to the Bay of Bengal. That's why this number has increased. If you look at basin wise like Bay of Bengal and Arabian Sea, so in this graph you can see that blue bar is showing the number of formation of the tropical cyclone over Bay of Bengal, and green bar is showing the number of formation of tropical cyclone in Arabian Sea. You can see generally the number of tropical cyclone formation over the Bay of Bengal is more as compared to the Arabian Sea. This was the 2019 was the particular year where the number of tropical cyclone formation was more as compared to the Bay of Bengal. So this was because mainly some research are indicating that that particular year the ocean heat content was very high in Arabian Sea. That's why the tropical cyclone formed more in Arabian Sea. Otherwise, the formations and frequency of tropical cyclone in Bay of Bengal is more. And why in Bay of Bengal the formation of the tropical cyclone is more? Because normally the sea surface temperature of the Bay of Bengal is more as compared to the Arabian Sea. And also another reason is most of the tropical cyclone form over the West Pacific Ocean, and because of the easterly wind, sometimes it is steered because due to the thin land mass. If you look at this back slide, if you look at the land mass between the Pacific Ocean and the Bay of Bengal, there is a very thin land mass. So it is sometimes it is steered toward the Bay of Bengal region, and if they will get the favorable condition, it forms into the tropical cyclone. So it will add the number. If you look at the percentage wise in 1997 to 2022, you can see the 35% contribution of Arabian Sea and 65% contribution of the Bay of Bengal. And if you look at the last 10 years, this number 1% has increased in Arabian Sea. Otherwise, there is not much change. And it is also noticed that the number of formation of deep depression and depression is significantly high as compared to the cyclone formation. If you look at this graph, you can see there will be the on an average 6 to 7 depression and deep depressions form over the Indian Ocean. But due to the not favorable condition, it not develop into the tropical cyclone. in the depression or deep depression stage itself, it disappear or it has vanished. So this is what is the favorable condition of the tropical cyclone. So this I have listed some condition. This is the necessary conditions only. This is not sufficient condition. Means if any tropical cyclone form, at least this criteria should be followed. This criteria should be there. First is the sufficient warm SST. If any tropical cyclone favorable condition or tropical cyclone forms, means SST should be greater than 26.5 degrees Celsius. If SST is 26.5 degrees Celsius, there will be the favorable condition for the tropical cyclone. So SST, this sea surface temperature, not only up to surface, it should be up to certain depth, up to 50-meter depth. This SST should be exist. Means throughout the water column, this temperature should be high. Then only tropical cyclone can sustain. And the criteria is the atmospheric instability. That atmospheric instability means this atmosphere should be unstable. There should be the temperature difference between lower atmosphere to mid-tropospheric level. Then only this tropical cyclone able to form. High humidity. So at the mid-tropospheric, the humidity should be high, around 50 to 60%. Sufficient Coriolis force. This is also one of the most important parameter for tropical cyclone formations. If Coriolis force is large enough, then tropical cyclone that maintain the speed of the tropical cyclone. So as you know that the Coriolis force over the global region, if you look at the global region with the latitude near the equator, it will be almost zero. If you go toward the pole, it will start increasing. So due to the very less Coriolis force near the equator, tropical cyclone cannot form plus minus 5 degrees away from the equator. Another criteria is the pre-existing low-level disturbance. So already there should be some low-level disturbance should be exist. If you look at this equator, there will be intertropical convergence zone. There will be different air masses, different temperature air masses will exist. If the ITC is further from the equator, so it will produce some thunderstorm kind of activity, thunderstorm near the equator. So that is the mainly seed of the tropical cyclone. Low level vertical wind shear. There should be a one low level vertical wind shear. Wind shear is mainly the change in wind speed with respect to height. So it should be less. It should be at least 10 meter per second. Then only the tropical cyclone sustain. If this wind shear will be high, then tropical what will happen? The moisture which is going from the ocean to about this atmosphere, it will cut off. That moisture is the mainly source of energy of the tropical cyclone. So tropical cyclone cannot sustain for longer time. So it should be less. That's why the tropical cyclone in monsoon season it not formed, because that time that vertical shear will be very high. This is how tropical cyclone form. Some basic information. First, the high humidity and sea surface temperature of more than 26.5 degrees Celsius are major contributor of the tropical cyclone formation. So first, like if the tropical cyclone form, there will be low pressure. What will happen? This evaporation start. Low pressure is there, evaporation will start, and water vapor will goes up with the height. There will be low due to the low temperature. It will condense into the water droplet, and it forms the cloud. So if this column of low pressure develop at the center of wind from the wind from around the column. So if this continuously this moisture is going up, and then there will be a low pressure column it form, and wind start rotating around the low pressure column. If this continue, so wind is start increasing. So this is the formation procedure, or this is the formation stage of the tropical cyclone. What is the energy potential of the tropical cyclone? Mainly, the energy potential of the tropical cyclone is warm water and humid air over the tropical ocean. So once this moisture goes up, it converted into the water droplet and form the cloud. During the condensation and during the conversion from water vapor to water droplet, it releases the latent heat, and this latent heat further it is converted into the kinetic energy, and this kinetic energy maintain the tropical cyclone circulation. This is the basic structure of the tropical cyclone. This is the vertical cross section, and then this is the horizontal structure of the tropical cyclone. If you look at the center, if you look at the center of the tropical cyclone, that is called the eye. Eye is mainly the cloud-free region and calm wind. Inside the eye, there will be the calm wind and no cloud. So this extent can be 30 to 60 kilometer in diameter, and also the lowest surface pressure and warmest temperature exist inside the eye. Inside the eye, your pressure will be very minimum, and temperature will be high. If you go toward the outer side from the eye, there will be a convective cloud wall, and this convective cloud wall is called the eye wall of the tropical cyclone. So it is basically a dense convective cloud. It rising up to 10 to 12 kilometer in the atmosphere. Inside the eye wall, the maximum surface wind exists, and maximum intensity of the rainfall is also exist. If any tropical cyclone hit the coast, so eye wall the region where the maximum rain occurs, and maximum damage also will be there in the eye wall. If you further go toward outside, so there will be the spiral band kind of structure you will get. That is called the rainy band also. So it is often extend up to 1,000 kilometers from the center. So these are the basic structure of the tropical cyclone. So how do tropical cyclone get their name? Because if any cyclone forms in any region, they will get the name. From where this naming has started. So the first, it started after the World War II, and subsequently it is adopted by all the region. In the most region, this name is based on the male and female name. But over the North Indian Ocean, the majority of the name is mainly based on the flower, animal, bird, tree, and foods. It is not based on the male or any female name. The first time this started since October 2014. So over Indian Ocean, the naming, how they will give the name. Actually, there is a neighborhood country. There is a 13 neighborhood country which contribute the name. So they give the list of the name, and from the list they will take one by one. Like if any tropical cyclone forms like tomorrow, so they will pick the name from one country, and if the next year any tropical cyclone form or any like October or November any tropical cyclone form, they will take name from the another country. So one by one they will take the name, and if this list complete, then again we'll go to the first country. So this is the procedure followed by the all the regional meteorological agency over this Indian Ocean. So if you you have seen this previous slide that in the northern hemisphere, tropical cyclonic wind rotate around the anti-clockwise direction in the northern hemisphere, and in southern hemisphere it rotates the clockwise. So what is the reason for rotating this wind anti-clockwise and clockwise? So this is the mainly responsible is the Coriolis force. Coriolis force is main force which rotate the wind in anti-clockwise direction. Look at this picture. If there is a low pressure, and surrounding it is a high pressure, the wind will move from high pressure to low pressure due to the pressure gradient force. And at the same time, the Coriolis force also start acting. The Coriolis force, if you look at this in northern hemisphere and southern hemisphere, due to Earth rotation, it set up an apparent force. This it has tendency, it will deflect the object in right direction in the northern hemisphere and left direction in the southern hemisphere. So due to this, if this wind start moving from high to low, if there will no another force, this wind will move straight. At the same time, this Coriolis force start acting, so it will pull the wind in right direction, and your this resultant path of the wind will be like that. And same time, if you look at this wind, so due to this Coriolis force, this wind start rotating anti-clockwise around the low pressure. The most important term is the landfall. Landfall, what is the landfall? Landfall is the event of the tropical cyclone coming onto land after being the water. If the tropical cyclone, because most of the life of the tropical cyclone, they spend over the ocean. And after spending the time over the ocean, when it comes to the land, that is called the landfall. These are the two picture, upper portion and lower portion of the picture. If you look at these two picture, in the upper portion is the situation of the landfall, and the lower portion is the not condition of the landfall, because the when we'll declare the landfall, when this I hit the coast, then only we call the landfall situation. In the upper portion of this image, look at this, I is inside the land or over the this coastal area, but in the lower portion this I is slightly away from the coast. So even though most of the part of the tropical cyclone inside the land, but we cannot call this is the landfall situation. So what will be the impact of the tropical cyclone? As we know that the tropical cyclone associated with the strong wind, storm surge, and heavy rainfall. So these are the main responsible factor for the damage. So due to the strong wind, what will happen? Due to the strong wind, there will be the damage of structure, loss of power and communication, and there will be loss of life and injuries, generation of devastating storm surge, destruction of vegetation and crop. So due to wind, these many things can be happen. And due to the storm surge, what will happen? There will be flooding up over the coastal area, erosion of beaches, loss of soil fertility from saline water. So once the tropical cyclone hit the coast, there will be the storm surge. So most of the means much water will come inside the land, and because due to the saline water, your soil fertility will be damaged. Loss of life, damage of structure. Due to the heavy rainfall, there will be loss of life, destruction of vegetation and crops, contamination of water supply, land subsidence, and flooding of land area. Now coming to the prediction of the tropical cyclone. So prediction of the tropical cyclone, not only the track prediction, it consists of many parts. So it starts from cyclogenesis prediction itself. What is the cyclogenesis? Cyclogenesis is the mainly you are going to predict, or you are going to monitor the formation of the tropical cyclone. Means at the low pressure stage itself, you are able to tell that this low pressure is going to develop into the tropical cyclone. So that is called the cyclogenesis prediction. Then after once the tropical cyclone form, there will be the track prediction. After that, and another most important parameter is the intensity. What will be the wind speed of this tropical cyclone? And once it near the coast, where will be the landfall going to happen? And once the landfall happen, what is the storm surge? So that prediction also is there. And after that, how much damage has happened? So these are many parameters which have to predict well in advance in time, so that we can evacuate the people or we can avoid the losses due to the tropical cyclone. So because you know that the tropical cyclone, most of their life spent over the ocean. So what is the observation over the tropical cyclone? So there is a ship measurement that also plays a very important role. They in the ship measurement, they take the ship into the ocean, take ship into the ocean and take the measurement about the sea surface temperature, salinity, winds, and all. But during the cyclonic disturbance, it will be very difficult to take the ship inside the ocean, in deep ocean. Another is the buoy measurement. Buoy is a floating buoy which installed into the ocean, and it measures the oceanic parameter like temperature, salinity, and wind speed and direction and all. Land-based observations also plays a major role, like radar and another in situ measurement which installed near the coastal area. Aircraft measurement also plays a very important role for weather measurement, weather parameter measurement. And next one is the satellite. So satellite, because the tropical cyclone lifespan is mostly far away from the land, and this satellite that time plays a major role. So to continuous monitoring and predicting the tropical cyclone, this satellite is very much important from any platform like geostationary, polar, and other thing. So it gives very useful informations to the forecaster, so that they can use this information into the model and they can predict the tropical cyclone track intensity and landfall position. So look, this picture shows the global network, the global satellite network. How many satellite there in the atmosphere, in the space, which are monitoring continuously our atmosphere and ocean. So we have a large network of this satellite. We have the QuickSat, TRMM, we are getting the rainfall, GOES-R, this is USA mission. Then FY1 and 3 launched by the China, and this Meteor, this is the Russia Federation. The Terra, Sumi, NPP, JSONs, and other GOES-R also is there from 75° west and 135° west. There will be the another satellite also. So many Meteosat satellite is there. And India also has launched so many satellites for atmospheric application. There will be INSAT series, INSAT 3D, INSAT 3DR, and OceanSat series. They have launched the OceanSat 1, 2, SCATSat 1, and recently they have launched EOS 06 for the atmosphere application. And Megatropics also one of the most important satellite which can provide the temperature and humidity profile of the atmosphere. So already so many thing has been covered in the previous lecture about the how this satellite image and how the satellite provide the information. I'll showing the in the concern of the tropical cyclone, how this satellite image can be useful for the tropical cyclone. There will be the infrared image, visible image, and water vapor. In the infrared image, it shows the temperature of the cloud top. So you can see in the infrared image, because this IR band cannot penetrate the deep cloud more deeply. So it only shows the cloud top temperature. So it shows how the deep organized convection of this cloud band. Satellite image not only shows the storm location, but also it shows the estimation of the intensity, because the certain cloud has a pattern characterized by particular wind speed. I'll discuss this how the wind speed intensity calculated using the IR image. Next is the visible image. Visible image shows the high value of reflectivity, because in the tropical cyclone, there will be the deep convective cloud, and there will be a water droplet. And due to the water droplet, due to the water droplet, high albedo is there, and reflectivity is more. So it shows very bright in the visible image. But the limitation of the visible image is it is not available during the night time. Another band is the water vapor channel. Water vapor channel shows how much moisture is present in the upper troposphere, and it is useful for indicating where rain is possible. So in the previous lecture, already have shown that how water vapor works, and at which portion of the atmosphere it gives the information. So it mainly shows the upper tropospheric moisture or humidity, how much moisture is available at the upper troposphere. So geostationary satellite is the ideal platform to detect the tropical cyclone activity, because tropical cyclone within 5 to 6 hours, this location is changing and continuously it is moving. So to locate or to monitor the tropical cyclone, we have to look continuously. So geostationary platform, if you take the polar satellite only 2 passes you will get over same area. So maybe within this time, the tropical cyclone location will be changed. So this stationary satellite is the ideal platform through which you can monitor continuously this tropical cyclone. But polar satellite also plays a major role in the numerical weather prediction model for the prediction. If you use the geostationary combination with geostationary and polar satellite, so it will be very useful for the better prediction. So this is the animation of super cyclone Amphan, which form over the Bay of Bengal region. You can see this is the inset 3D image, IR image. Middle one is the visual image, and right panel shows the water vapor. So this is showing how the tropical cyclone moving toward the West Bengal. So for the continuous monitoring, this plays a major role. And in the visible channel, you can see during the night time, there will be no observations. Only daytime, it is available, and you can get the information through the visible channel. This is the initial 3D observations for the Bipros cyclone. You have seen this Bipros cyclone is formed before the onset of the monsoon. It formed over the Arabian Sea, and it hits Gujarat coast. So this is the TIR thermal infrared brightness temperature. You can see over this deep convective cloud region, this brightness temperature value is very low. And if you look at this surrounding area, this brightest temperature is around 300 to 320 Kelvin. So using this IRR infrared image, you can monitor the tropical cyclone continuously. And this is the observed track of the tropical cyclone, which form over the Arabian Sea. It has a very long track, it is started from 6th June itself and at the coast, Gujarat coast on 15th June. So I'll tell you some applications about that scatterometer satellite. So scatterometer satellite gives the wind information, which is very important for the tropical cyclone monitoring. So SCATSat 1 has launched by the ISRO in 2016. It is the continuous mission of OceanSat 2. It provides the wind vector for the weather forecasting and cyclone detection and tracking. So major objective of this SCATSat was the weather forecasting, cyclone prediction, along with the ocean state monitoring and prediction. So this in the scatterometer, there will be 13.51 gigahertz KU band was there. And it can measure the wind speed in the accuracy of 1.8 meter per second RMSC within the limit 3 to 30 meter per second. Wind direction, it can measure 0 to 360 degree with the accuracy of 20 degree root wind, that RMSC. And it has a spatial resolution 25 kilometer by 25 kilometer grid. And it has a swath of around 1400 kilometer for inner beam and 40 kilometer for outer beam. So, but the KU, because it has a KU band has some limitation also. KU band is more sensitive to rain contamination, which can lead to overestimate of the wind. So recently, ISRO has launched the EOS 6 satellite. It is also the continuation mission of the OceanSat 2. So this provides the continuity service for the OceanSat 2 spacecraft with enhanced payload specification as well as the application area. So it has 4 payload. One is the ocean color monitoring. It is to observe the ocean color and other parameter of the ocean. And there is the SSTM, sea surface temperature monitoring, to monitor the sea surface temperature of the ocean. KU band scatterometer is also there because SCATSat now life cycle is over. So it is the continuity of that one. So wind vector data used in the oceanography, climatic and meteorological application. This Argos is a communication payload that is communicate from the floating Argos and ships and all. So application of this scatterometer, how it works? Mainly, it is the active microwave sensor. It because it is active sensor, so it send the energy to the Earth surface and ocean surface. So if we fall over the ocean surface, because the ocean surface, when the ocean surface is rough, so it will reflected back to the sensor. So there will be if ocean surface is rough, there will be due to the capillary wave. And this capillary wave, due to the capillary wave, what will happen if the wind speed is very low? So this wave will be small. If it is high, so wave will be large. So it depends upon the wind speed. So based on that, they measure the wind speed and wind direction by viewing the same patch of the ocean from several angles. So in this way, it measures the wind speed and direction over the ocean, which is very useful and important for the tropical cyclone monitoring and prediction. So this is one of the picture of taken by the EOS satellite for the Bifrost cyclone, extremely severe. The Bifrost cyclone was the extremely severe cyclone. So you can see it has captured very well this high wind speed and the direction of the tropical cyclone. You can see this high wind speed exists over this area. And this circular, because this is the surface wind, so you can see the movement and the direction of the wind. So I'm going to tell about the some more application about the spectrometer. So one of the scheme developed by scientist Neeru Jaiswal and Dr. C.M. Krishnawal for prediction of the cyclogenesis using the spectrometer wind. So they have used the wind pattern matching based approach to monitor, to predict the cyclogenesis. So basically, the surface wind pattern of developing system have some similarity, which has been quantified in the wind pattern matching approach to predict the tropical cyclogenesis. So a database has been prepared for using the past developing system, and once the any tropical cyclone form in the real time, they are predicting the cyclogenesis. So this is the flow chart of this algorithm. First, they have prepared the database from 2000 to 2008, taken the database from 2000 to 2008. During that time, they have taken the image from the QuickScat. QuickScat is also a spectrometer satellite. They are providing the wind. So they have taken the data during the cyclone phase, starting from low pressure to up to cyclone formation. So before once the tropical cyclone has declared, before T minus 96 hours prior, they have taken the data from the QuickScan. And this and the next step, they have done the data cleaning. In the data cleaning, they have sent, because this is the polar satellite, QuickScan is the polar satellite. So sometimes the passes over the tropical cyclone is not covered full of the tropical cyclone, or sometimes this if you going to hit the land, this passes is not cover the full tropical cyclone size. So they have considered if they are covering more than 60%, then only they have taken the data. Otherwise, if it is less than 60%, they have discarded. And in next step, what they have done, they have taken not whole image, they have taken the image around the center. So they have taken the block of the size 31 into 31 block. So in that domain, they have cut the data and stored in the database. Once in the real time, any tropical cyclone forms, they try to match this wind pattern with the real time wind. So they have used the vector block matching algorithm. This is they have taken the reference scene, which is coming from the database, and alias scene, which is coming from real time, from any spectrometer data. And they have used this formula to compute the matching index. So they have considered the wind vector as a complex number. So based on that, they have computed the matching index. If the matching index is maximum, that point is considered the center of the tropical cyclone. Also, if the matching index is greater than 0.6, so that low pressure, it has a potential to develop into a tropical cyclone in future time. So they have set the threshold for that low pressure. If this Cmax is greater than 0.6, then only this low pressure will develop into the tropical cyclone. Means low pressure has a potential to form in the tropical cyclone. So how the matching has been done, you can see this is the database wind pattern, and this is the real-time wind pattern. So each and every grid point, they have computed this C value, matching index, like this. So where the matching index has found maximum, that point they have considered at the center of this low pressure, and this low pressure, definitely it is going to develop into the tropical cyclone if Cmax is more than 0.6. So using this algorithm, they have predicted so many cyclogenesis in real time. This is the cyclogenesis prediction of the Amphan cyclone. This is the wind vector on 15th May 2020. You can see the matching index is 0.69. So tropical cyclone has declared on 16th Before that, they are able to tell that this low pressure or this depression, deep depression is going to develop into the tropical cyclone. These two images showing the cyclogenesis prediction of the Nisarga cyclone, which form over the Arabian Sea. So you can see on 1st June, before the tropical cyclone formation, this matching index was found around 0.65 and 0.68. So because it is greater than the threshold, so this low pressure definitely will develop into the tropical cyclone. Another application of the spectrometer data is because using the satellite and all, you can continuously monitor any weather phenomena, but you cannot predict. If you want to predict the weather phenomena, you have to use the model. So the role of the satellite data is you can use this satellite into the model through data assimilation and other technique. You assimilate this observation in numerical weather prediction model and try to improve the forecast. So spectrometer data, this data has been assimilated in NCMRWF GFS model. If you look at this spectrometer data has been taken for 3 cyclones, that's Kayan, Nada, and Vardhan, which formed in 2016. So these 3 cyclones has been taken as a case study. This spectrometer data has been assimilated. Look at this picture. This wind pattern, wind vector is two-type experiment. Actually, two-type experiment is conducted. One is without scat set, and another one is the with scat set. In the without scat set, if you look at this wind pattern, it is not well developed cyclonic circulation. You can not see in this image. But once you have assimilated this scat set observation, very well structure of the wind pattern of cyclonic wind, you can see in this image. So in conclusion, this impact has been observed and it has been noticed that if you assimilate this spectrometer observation into the numerical weather prediction, it leads to improvement of the track and intensity and landfall information. So it has been noticed that scat set observation impact is larger in the case where observations are located in the vicinity of the cyclone position at the analysis time. Because this is the polar satellite, so sometimes this observation is away from the cyclone position also. So in this study, they have found that if this observations over the cyclone portion, so they have found a more positive impact. And based on the average error of 3 cyclone, it has been found that the track error has got reduced as compared to the without scat set observation. You can see this is the one of the example. You can see this blue track is the control run where scat set data has not assimilated, and red one is the track which is after assimilation, and black is the observed track, IMD based track. So you can see after the assimilation of the scat set wind, this track has got improved. So also mean absolute error, it shows the intensity forecast of three cyclone also got improved once the scat set observation assimilated into the model. Another important application of this satellite data is the center detection using the infrared image. Infrared image, how you can detect the center. So one of the algorithm developed by same that Neeru Jaiswal and Dr. C.M. Krishnawal, using the using the Kalpana image, they have find that algorithm. They have developed the algorithm, and this algorithm can be applied for the any infrared image. So in this first, they have taken the sample image from the Kalpana satellite, this infrared image. So because they have taken only the, they have cut the image only over the portion where tropical cyclone is located. So they identified the scene of the interest, this size around 401 to 401 blocks. And after that, they have, because this is the brightness temperature value, so they have computed the variance of the image. So for the each pixel they have computed, and in this image you can see the low value of the variance also. So to compute the variance at each pixels, the deviation of its brightest temperature value from the mean brightest temperature value in neighborhood of 3 cross 3 domain, they have grid points they have computed. And the pixels where this low value of the variance indicate the high level of axis symmetry neighborhood surrounding that pixel. So this is the characteristic feature of the vertex that form around the center, where the low value of the variance you can see. And further they have computed the gradient of this flux. So gradient of the brightness temperature in the variance image is calculated from the zonal and meridional derivatives, and then they have drawn the parallel to the gradient vector at each pixel of the analyzed scene, and the point where the these lines intersect each other are stored as a score in the density matrix. And then pixel with the maximum score in the density matrix is the location from where the maximum number of gradient line is passing. And the center, then they have obtained the center by using some correction filter. They have corrected this value and they have located the center position. So using this algorithm, they have detected so many cyclone center using the IR image. So this is the center detection done by this one for the Amphan cyclone. You can see seeing this image, you cannot identify the center, where is the center, but using the algorithm you can easily, or you can accurately, you can find this center location of the tropical cyclone. And this is the brightness temperature control also. You can see this brightest temperature, low brightness temperature can be observed. And this is the center position identified this algorithm for the Bifrost cyclone using the INSET 3DR image. Now coming to the intensity. Intensity is also one of the most important parameter for tropical cyclone. What is the wind speed? So there is so many method for intensity prediction, but one of the most reliable method is the Devereaux technique. So Devereaux technique, most of the agency, regional meteorological agency are using to predict the intensity using the Devereaux technique. So Devereaux, this name has been taken from the Van Devereaux, which was an American meteorologist who has developed this technique in early 70s or 80s. And then further, this scheme has been modified by the older and Weldon, and it is called the advanced Devereaux technique. So this technique is basically based on the pattern matching. So they have considered the cloud in, they have categorized cloud in the four basic pattern. First is the curve band pattern. Curve band pattern is you can observe in the early stage of the tropical cyclone when it is developing stage. And this pattern is categorized by the band of dense cloudiness that begin to curve around the center of the star. In the weak cyclone, the band coil entirely around the center of the star. And next one is the shear band pattern. you will see typically in the formative stage of the tropical cyclone are during the weakening. And the shear band pattern is categorized by the deep convective cloud moving to the one side of the storm center. And another pattern is the central dense overcast pattern. In this dense overcast pattern, describe the region of the dense cirrus cloud that is the core of the tropical cyclone, which is sometimes observed in the stronger tropical depression, tropical storm, and weak cyclone also. Eye pattern is visible when the eye is clearly visible, then we'll call the eye pattern. So how this scheme works, I'm going to explain that one. So mainly this is the flow chart of that scheme. First, they have taken the data, IR images. They have first located the cyclone center. They first located the cyclone center. Where's the cyclone center? Then they have selected this cloud pattern, and assigned the T number. T number is basically the unit represent a typically 1 day intensity change based on the climatological data. So in the Dirac technique, this T number varies from 1 to 8 scale in the interval of 0.5. And same time, they have assigned the model expected T number, analyzing 24-hour trend. Using the previous 24-hour, how the intensity is changing, they have trained, they have modeled it, and then assigned the model expected T number. Actually, model expected T number is the intensity estimates from the 24-hour old final T number and the determined intensity trend. Then they have given the pattern T number. Using the data T number, pattern T number, model expected T number, they are computing final T number. That final T number is basically the intensity estimates from the given time selected from the data T number, pattern T number, and model expected T number. It is used with a set of rules to determine the final current intensity number. Final current intensity number this time, and model expected number of 24-hour later. So applied the final T number to compute the current intensity. And then they forecast the 24-hour intensity. Forecast intensity number is based on the current intensity and observed signal in the cyclone cloud pattern and the environment. So finally, the current intensity number they will get if it is 1.0. So for that, they have assigned 24 knots speed is there. If it is 1.5, then it is 25 knots. If 2.0, it is 30 knots. If 2.5, it is 35 knots. So like that. If the intensity is this T number is 8, so this maximum wind will be the 170 knots. So based on that, they are able to predict the intensity of the tropical cyclone. One of the applications of the megatropics, because one of the most important mission launched by the ISRO, megatropics, that provide the tropical region, they provide the temperature and moisture profile over the tropical region. So it has, it had 4 payload. One is the Madras, another is the Saphir, that sounder for probing vertical profile of humidity, and SCRAP, scanner for radiation budget. It is for long wave radiation fluxes, and ROSA, that radio occultation sensor for vertical probing of the temperature and humidity, that for the GPS receiver at L1 and L2 channel, and temperature and humidity profile. So from the we are going to discuss about the importance of the Saphir data. So Saphir has a 6 channel at 183 gigahertz that provide the atmospheric profile of humidity and temperature. So this is the weighting function of the SAPIR. You can see you can get the temperature profile up to 10 to 12 kilometer in the atmosphere. So the dynamic range of brightness temperature is 4 Kelvin to 313 Kelvin. Special resolution of this SAPIR observation is 10 kilometer and swath is 1705 kilometer. So you can this is the 1 day observation, because it provides around 13 to 14 passes over the tropical region. So if you plot together, so you will get the whole coverage over the tropical region. So this is example of the observation from SAPIR. One of the impact study.
Dr. Sanjeev, can you quickly finish the lecture, because next speaker also has joined.
Sure, sir. So impact of the SAPIR observations, one of the study done by me, I have seen that when we assimilate this SAPIR observations into the model, so it leads to improvement in the humidity and as well as the track also. So this is the RMSE difference, because two experiment is conducted. One is the without SAPIR observation, and there is the with SAPIR observation, and the RMSE difference has been taken between the experiment and the control run. So you can see this RMSE, this red is the negative RMSE, and RMSE difference. This is the RMSE difference mainly. RMSE in experiment run, RMSE in the control run. So the negative value shows the improvement in specific humidity, and this green value shows the degradation of this specific humidity. So it is tested about two cyclones that form in 2013, that Helen and Leher. So you can see if you assimilate this SAPIR observation into the model, so it will improve your model field. So these are the list of the satellite observations which are used for assimilation in this numerical weather prediction model, and it will further improve the tropical cyclone forecast accuracy. So there are so many so many observations from you can see the atmospheric motion vector from geostationary satellite, scatterometer wind. We are assimilating the radiance observations, observation from geostationary and low Earth orbiting satellite. We are getting from GOES, METEOR, SAPIR sounder, megatropics, and imager insert 3D, 3DR. Precipitation rate also we are getting and assimilating into the model. GPS RO bending angle, brightness temperature from hyperspectral satellite also we are assimilating that radiance observations. You can say GPS IPW also we are getting and assimilating into the model. Satellite derived ozone data also assimilating into the model. So these all satellites are very useful for the tropical cyclone prediction. So this is my last slide. So all this, whatever we have discussed in this slide, all the forecast, real-time forecast is available on the Scorpio website. You can get from the MOSDEC. Here is the https www.postdec.gov.in/Scorpio. The full name is the Satellite-Based Cyclone Observations for Real-Time Predictions over the Indian Ocean. So you can get all the information like cyclone center, what is the cloud height, what is the matching index for the cyclogenesis using the OceanSat 3 EOS 06 spectrometer observation. So you can browse it. Thank you for your attention.